So here's part C of number 2 from the 2013 AB exam. And part C wants us to find all times in the interval from 0 to 5 where the particle changes directions. Justify your answer. Well, this is a calculator problem, and if you looked at the video for part A, in part A I graphed the velocity function, so I still should have that on my calculator here. Now in part A I graphed these lines as well. I don't need those anymore here in part C, so I'm going to get rid of those. And I'm going to have my window go from the x value of 0 to the x value of 5, so that I'm looking at the graph that represents the interval that this function holds for. So here's the graph of velocity. And if you think about the graph of velocity and being asked to determine where the particle changes directions, the particle changes directions anytime the rate of change of the position of the particle changes signs. The rate of change of position is velocity. So really, we have a change in direction anytime v of t changes signs. So we're looking for sign changes on the graph of v of t. This happens as we cross this t value right here, so it appears to be, I don't know, somewhere between 0 and 1, and then it appears to change signs again somewhere between the t value of 3 and the t value of 4. We want to find those times, so we're just going to have to take a minute with the calculator to find the zeros of this velocity graph. So for the first 0, if we just kind of bring our cursor way over to the left of that first 0, for our left bound, that'll be good enough. Right bound, be good enough. Enter. So we have a change in the direction of the object at approximately t equals 0.536 if you're going 3 digits of accuracy, as we always should. We just have to do that one more time. So if we grab the 0 feature from out of the calculator once more, for the other 0, left bound, I can hit enter anywhere here, and then for the right bound I just have to get over to the right of that other 0, and then I guess just try to get close. So the other 0 is at approximately 3.31, and I can leave it as 3.317, meaning I'm truncating the decimal and cutting off everything else. But if you want to do the typical rounding, you'd round that to 3.318, and you do want to carry 3 digits of accuracy. So we have 2 times when the direction of the object changes. It happens anytime velocity changes signs. The object changes direction as we cross this t value, and again as we cross this t value. We use the calculator to find those t values.